Good day everyone. In this video, we will be learning all about quadrilaterals. This is a continuation of our lesson last time all about trapezoids and parallelograms. So, if you haven't watched the video yet, please do so as this is already a continuation of that first video about quadrilaterals. Just to recap, in this lesson, we should be able to answer this essential question. How do you sort and classify quadrilaterals? And based from our previous lesson, a quadrilateral is a polygon with 4 sides and 4 angles. Let me show you first as part of our review what are trapezoids and parallelograms. So, all 4-sided figures that only have one pair of parallel sides are what we call trapezoids. Parallelograms, on the other hand, has 2 pairs of parallel sides and 2 pairs of opposite sides that are equal in terms of length. Now, focusing this time about parallelograms, we will now check for its side lengths and angles. So here are some common examples of parallelograms. Some of you might be already familiar about how to call each one of them, but in order to complete this lesson, let us look closely at their properties to make sure as to how do we call that specific shape that we are given. Next, starting with the square. So, based from our lesson last time, that using tick marks, so in this case, if I will put all of these sides with tick marks and one for every side, it means all of the sides are equal. So for this one, we have all sides are equal, yes. And then, if you will look closely at its corners, we will have 1, 2, 3, 4 sides where we can form right angles. So, in this case, we have 4 right angles. And then, since all of the sides are equal, we can say as well that opposite sides, so this side is just equal to this side is also equal to this. So, we can say that we have 2 pairs of opposite sides that are equal. Then, parallel sides, there is 2 pairs. Always 2 pairs because we are talking about parallelograms. Again, going back to the definition of parallelograms, it always has 2 pairs of parallel sides and 2 pairs of opposite sides that are equal. So let's go back to this figure. Now, who among you knows what do we call this shape? Correct. This is what we call a square. Okay. Now let's move on to the next figure. So going back with our raw drawing, let's try to expand this figure using one direction only of its sides. So let's try to stretch a bit our figure like that. And then, so for this one, since it's still a parallelogram, I can say that there are 2 pairs for parallel sides, 2 pairs for opposite sides that are equal. We did not change any angles, so therefore there's 4 still. But this time, since we tried to stretch the length of our figure, are all sides equal now? The answer would be no. This figure is a classic example of rectangle. Okay, so rectangle. So always remember, square, rectangles are both considered as parallelogram as well because of its characteristic that it has 2 pairs of parallel sides and opposite sides are equal. Another shape that we can actually have, let's go back again to the same raw shape that we have earlier. So going back with our square, let's try having the angles itself to be changed. Okay, so we will have stretching this one in terms of angle. So it will look like this one. So in this case, we will have this side and this side, this and this from a square. All of them are still the same. So yes, for our sides. But then here, no right angles are formed anymore because we tried to slant down our square a while ago. So none for right angles. Then opposite sides are equal. There's still two pairs. Two pairs as well for parallel sides. Can you guess how it's called? Correct. This is what we call a rhombus. Okay? A rhombus is actually a sort of mother of the property of square that it has all of its sides that are equal. Then rectangle is where the square got its all four right angles. Okay? Now going back to this same figure that we have. So from this slanted square, let's try to stretch a bit more of one of its length. So it will now look like this one. Okay. So in this case, there are still two pairs of parallel sides, this and this. Okay, so parallel sides can be denoted by arrowheads. So this and this. Then the second pair would be this portion and this. So there are two pairs. For opposite sides that are equal, this with one tick mark has both of its side lengths equal. Then opposite to it, for these two sides are also equal. So similar, since it's still a parallelogram, there would be two pairs. Are there any right angles in this particular figure? None. Are there any equal sides there, or are all the sides equal? Also a no. If that's the case, that there's no right angles, no equal sides at all, then this is a generic example of a parallelogram. Okay, so to summarize our lesson for today, for parallelograms, there are four kinds of them. So we can either call them as a parallelogram. If it has all four angles, we can call it as rectangle. If you have four-sided figures with two pairs of parallel sides and two pairs of opposite sides that are equal, but no right angle and all the sides are equal, that's what we call a rhombus. Combining those special properties of four right angles and all the sides are equal, that's what we will have for square. In relation to that, this would be the summary for classifying quadrilaterals. So again, based from the pair of parallel sides, we have parallelogram and trapezoid. Trapezoid only has one pair of parallel sides. Parallelogram only has two pairs. Okay? Then, rhombus and rectangle, they're just different in terms of the side length. Rhombus has all equal sides. Rectangle has all four right angles. Combining those special properties, we will have a square. If you have any questions, please do send me a message. Thank you for watching.